Happy learning to the smart learners. I am Dr. Shobha Edward, Principal, Associate Professor and Head of the Department of Corporate Secretaryship, KCS Kasinagar College of Arts and Science, here to elaborate on the measures of central tendency. So you will be seeing measures of central tendency in detail. So as we move on to the measures of central tendency, it is nothing but the averages. It is a single value to depict the whole set of data that is given. The entire data is depicted by a single value and it includes the mean, median and mode. The characteristics or essentials of a good average are that it is easy to understand, simple to compute, based on all observations, rigidly defined and capable of further algebraic treatment with sampling stability, and it is not affected by the extreme values. So these are the characteristics or the essentials of a good average. The functions or uses of an average, it's a shorthand description of mass data and it is a common denominator for comparison. It measures typical size. Clear picture of the entire group of data is given. The following are the important measures of central tendency. They are nothing but arithmetic mean, median, mode, geometric mean and harmonic mean. So the requisites of a good average, which you've already seen as a recap: easy to understand, simple to compute, based on all observations, rigidly defined, capable of further algebraic treatment, sampling stability, not affected by extreme values. Now the different types of averages in detail. So they are the arithmetic mean, median, mode, geometric mean and harmonic mean. Arithmetic mean is obtained by dividing the total value by the number of values. The total is divided by number of values that are given. That is the arithmetic mean. The merits of it: simplest to understand, easiest to compute, and it's affected by every value in that data. It's defined by rigid mathematical formula. Subsequent algebraic treatment is reliable. Center of gravity balancing the values. Calculated value not based on position. It's not a positional value. The limitations: extreme values will affect the average, and in open-end classes, mean will not be computed. You will have to make assumptions, and it is not always a good measure of central tendency. Now the median is a central value, the middlemost value, which divides the data into two equal parts. The merits of it: you can use it even in open-end classes. Extreme values do not affect the median. In skewed distributions, you can use median, and it's a most appropriate average, and you graphically also you can determine the median. Median indicates the middlemost value in the distribution. Now the limitations: we have to arrange the data to find the median. It's a value which is not determined by each and every observation, and it is not capable of algebraic treatment. It's affected by sampling fluctuations, and when we have even number of values, we have to get the approximate value for the median. So we do the approximation if the number of values given is even, and it is erratic if the number of items are very small. Now moving on to the mode, it's the value that occurs with the greatest frequency. The maximum number of times a value occurs, that is the mode. It possesses the merit of simplicity. In discrete series, you can find it by just looking at it by inspection. It is commonly understood, and it is an average which people use in day-to-day livelihood. So, for example, the average size of ready-made garments, the typical size of land holding are examples of the use of mode. And mode is the most common item of a series, and it is not an isolated example. So, this is the most frequently occurring item. It is not affected by the value of extreme items if the distribution follows natural law relating to extremes. So usually there's little concentration of items around extreme values, and it can be correctly calculated in open-end classes. In continuous series also mode can be calculated even if all the item values are not given. Only the modal class and the frequencies of the adjoining class are required to compute the mode. Mode is ill-defined, that's a demerit when it is bimodal or multimodal. So if you have two modes, it's bimodal. If it's more than two modes, it's multimodal. And you cannot define the mode, so it is ill-defined. It is not a representative average as far as it is concerned. In an example, if in a series of 1000 items, 20 have a particular value and the other values have frequency less than 20, the mode becomes 20. But certainly 20 is not a typical representation of the average. It is not capable of further algebraic treatment. It is affected to a great extent by the fluctuations of sampling. Now, moving on to geometric mean, it is the nth root of the product of n observations. So, if you have n observations, the nth root of the product of the n observations is the geometric mean. The application of geometric mean is used to find the average percentage of increase in sales, increase in production, increase in population, etc. It's the best average in the construction of index numbers. It is suitable when large weights have to be observed. The merits and limitations, it is determining the ratio of increase or decrease. So when you have a percentage or when you have a comparison in increase or decrease, you apply the geometric mean. It's capable of algebraic manipulation, difficult to compute and interpret, and it can be computed when there are both negative and positive values. So that becomes a limitation for it. The harmonic mean is the reciprocal of the arithmetic mean, and it is also applied for computing the average rate of increase. So the rate of change in speed, the rate of change in share price movements, for such situations we use the harmonic mean. The merits and limitations of harmonic mean are, it's useful in special cases, can't be computed when there are both positive and negative observations, gives largest weight to smallest observations, and it is rarely used. So this is the limitation of harmonic mean. Now going on to the mathematical properties of arithmetic mean. The algebraic sum of the deviations of all observations from the arithmetic mean is always 0. That is, x minus x bar is always 0. And the sum of square deviations of all the observations is minimum. If we have the arithmetic mean and the number of observations of two or more related groups, we can combine it together and we can find the combined arithmetic mean. So if we have arithmetic mean of one group and arithmetic mean of another group, we can do the combined arithmetic mean for both the groups together. So this is the mathematical property of arithmetic mean. Now, what is this arithmetic mean? What we've already seen is dividing the total value by the number of values. And the types of arithmetic mean, we have the simple arithmetic mean and the weighted arithmetic mean. In a simple arithmetic mean, all items of a series are given equal importance. In a weighted arithmetic mean, different items are assigned weights and according to their relative importance, they are given weightage. So, weighted arithmetic mean is based on weights, and simple arithmetic mean, each and every value is given equal importance. Now, the merits, a recap of what we have already seen, the merits and limitations. Simplest, affected by every item, rigid mathematical formula is there, subsequent algebraic treatment is possible, center of gravity, balancing the values, and not based on position. The limitations, extreme values affected. In open-end classes, mean can't be computed, and it is not always a good measure of central tendency. Now moving on to the merits and demerits of median. This is also a recap. Useful in open-end classes. Extreme values do not affect skewed distributions. It is used. Most appropriate. Determined graphically value of the middlemost item. The demerits, necessary to arrange data, not determined by each and every observation, not capable of algebraic treatment, affected by sampling fluctuation. When number of items is even, it is only an approximate value that's given as median. Erratic if the number of items is small. The merits and demerits of mode. The simplicity. In discrete series, you can find it by inspection. Commonly understood. Most common item in the series and not affected by the value of extreme items. Correctly calculated in open-end classes. In continuous series, only the modal class and its frequency is sufficient to calculate the mode. The demerits, it's ill-defined if it's bimodal or multimodal, not a representative average, not capable of further algebraic treatment, affected to a great extent by the fluctuations of sampling. Now the empirical relationship between mean, median and mode, how they all are related. So, a distribution having one mode is unimodal. If there is more than one mode, it's bimodal or multimodal. If it's two modes, it's bimodal. If it's more than two modes, it is multimodal. And then in that case, if it is bimodal or multimodal, it is ill-defined. So, you won't be able to define the mode. So, in that case, we use the empirical mode. The empirical mode is given by the formula 3 median minus 2 mean. 3 times median minus 2 times mean. That is, empirical mode is nothing but 3 into median minus 2 into mean. This is how you give the empirical relationship among mean, median and mode. The advantage and disadvantage of geometric mean. So, useful in averaging ratios and percentages, capable of algebraic manipulation, difficult to compute, can be computed when there are negative and positive values. Going on to the application or the uses of geometric mean, it is to find the average percent of increase in sales or production or population, etc. It's the best average and most suitable when large weights have to be observed. The merits and demerits of harmonic mean, it's useful in special cases, can be computed when there are both positive and negative observations, gives largest weight to smallest observations, and it is rarely used. So this is for your measures of central tendency in elaborate. So thank you and happy learning. It's smart learning from Dr. Shobha Edward, who is signing off from you. Thank you.